goal today says I can write, graph, and solve problems involving direct variation. So we're doing 3 things on the flappy, and then we're doing 1 thing on the back where we have to write problems down, so we're going to have to move. Is everybody ready? Yeah. I need you to be ready, and I need you to get on my pace. I don't think that's problem. Alright, so in a table, you're going to be given a table of values, and you're going to look at the slope. You're going to look at the change in y divided by the change in x. Now, direct variation deals directly with slope, and it passes through the origin of a graph. So it's the change in y divided by the change in x. That's what we did yesterday, correct? So we're applying what we did to a specific kind of situation. Alright, so a direct variation between 2 quantities is a relationship in which the ratio of one quantity to the other quantity is constant. That means that it makes a linear graph, that the slope stays the same. Alright, so let's look at A. It says determine whether each of the tables below represent a direct variation. So first, let's look at our x values. How much do we increase between 1 and 2? 2 and 3. 3 and 4. 4 and 6. Okay. Now let's look at 6 and 12. 12 and 18. 18, 24. 24, 36. 12. Now, is this consistent? And before you say no, think about what happens. Why?
Because it goes up by 2 on x, on y it goes up by 12.
So it's doubling, right? Awesome, good, take a point. So what would the direct variation be here? It would be 6 divided by 1, which is 6. So it's yes. Questions? Yes.
Well, like, if the number is continuing, but then it starts to calculate, but if something else, will it still be constant?
Yes. Yes. Because as long as it still goes in the same pattern, that's fine. Alright, let's look at B. Are we increasing or decreasing on our x-axis? Increasing by what? And then? And then? And then? Awesome. Alright, let's look at our y. Are we increasing or decreasing? Okay, what about 14 to 7? 7 and negative 7. And then we're decreasing by 7 again, right? So is this constant? Yes, it's the same situation, right? Where we increase or decrease by 2, we increased by 2, and we just skipped a term here. We decreased by 7, we just skipped a term here. So this would be yes. Alright, what about C? Looking at C, what do you think it's going to be? No, because that's a lot of craziness, right? But let's check just to make sure. How much are we increase? What's happening between 8 and negative 4? Decreasing by how much? Good. Negative 12. Take a point. What about negative 4 to 96? $100. Who said that? Take a point. Alright, now, instead of going all the way over, I want to look right here. How much are we decreasing from 6 to negative 12? Negative 18. And what about negative 12 to 0.5? Is it 11.5? Okay, guys, to get to 0, how many units do we have to go? Yes, it's 12.5. Think about it this way. When you're going from negative to positive, think about how many units you have to go to get to 0, and then you can add the rest. So to go from negative 12 to 0, that's 12 units, and then you add 0.5, so it's 12.5. Now, in your calculators, well, we can just look at this. It's the change in y divided by the change in x. Negative 18 divided by negative 12 is not going to be the same thing as 12.5 divided by 100, is it? So the answer is no. Do D without me. Okay, do problem number D and no one will die.
Yeah.
Tyler, are you studying for your test? You are doing something? Okay, good. I'm super proud. Pardon? Okay, good. Thank you so much.
Oh, okay.
We'll see. We'll see. What, City? Put it in the tray. Alright, did we get yes or no? Who got yes? Who got no? Who doesn't know what they're doing? Okay, why don't you know what you're doing?
I'm just special.
Well, okay, so someone besides him. What happened, Jared? Did you just get confused halfway through?
I just don't have a calculator.
Well, Tater Tot, how do we remedy that situation? Yes. My ham sandwich. You're welcome. Okay, so let's go from negative 32 to 80. What did you get? 112. Okay, what about negative 2 to 5? 7. Okay, what about 80 to negative 48? Negative what, baby? Negative 128. And what about 5 to negative 3? Negative 8. Alright, divide those two numbers. Do 7 divided by 112 and negative 8 divided by negative 128. Remember, you do y divided by x. The change in y divided by the change in x. Did you get the same thing? So what's the answer? Yes. Dun, 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 dun. Any questions on tables? I think you have like maybe one like this on your quiz or your test. Maybe one. Maybe. Alright, so let's look at with an equation. With an equation, it's always in this form. There's no plus or minus out here. It has one term, it's right here, and it has a y-intercept of 0. A y-intercept of 0. It passes through the origin. Does everybody understand? Are we ready? Yes. Ready, 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 Freddy's. Alright, open this flappy. Alright, so a direct variation can be written as an equation in the form of y equals kx, where k represents the slope. I don't know why they chose to use k instead of m. I cannot answer this question for you. It is silly and ridiculous, but it needs to look like this, and k is the slope. Okay, so now it says, tell whether each equation represents a direct variation. If so, identify the constant of variation. The constant of variation is k. It's the slope. So this one, does this look like our base form of y equals kx? Yes, it does. And our k would be 6. That's all you do. Isn't it lovely? Alright, what about b? The answer would be no, because it has a -1. Yeah, so it can't have a plus or minus in it. Unless it has a 0. Alright, what about c?
Yes.
Yes, and what does k equal? 1/2. Take a point. What about d?
No.
I'm not sure if that was a yes, no, or Gus.
I said no.
It is. Divide both sides by 3 to get y by itself. And you would get y equals 2x. So that has y and x alone. And what is your k? 2. Alright, what about e? Does it have a plus or minus in it? So
It
it's
doesn't have.
yes. Now, let's get y by itself. Divide both sides by 5. What's the number in front of x? So it's 1/5 x. So what's our k? 1/5. So far, we've had 3 yeses, and they all only have a y and an x. And what did our no have in it? A -1. So it had a constant. It can't have a constant. So let's look at f. This is a great problem. Let's solve it for y. Now, how would we solve this equation for y? What would we need to do first? Add 15 next to both sides. Good. Take a point. And then what would I need to do? Divide by what? And what's 15 divided by 5? Now, is y by itself? Do we only have a y and an x? So the answer is yes. And k is 3. Does anybody have any questions? Okay, what do you think about the last one? No. Why? It has a plus. It is a +6, right? It is a constant. So it can't have a constant. For it to be a direct variation, it can't have a constant. Are we ready for a graph? And then we're going to talk about where we can really use this. So a graph, it must pass through the origin. It must pass through the origin. This is what a graph of a direct variation looks like. It has to be linear, and it has to pass through the origin. Ah. All right, let's open this. All right, so the graph of a direct variation is always a linear function that goes through the origin. Are you ready? Are you ready? Are you ready? Okay. A, it says graph each direct variation below. So it passes through the origin, put a dot on the origin. 3 is our slope. That's our k. And it's a +3. So are we going to be climbing the hill or falling down it? And so you go up 1, 2, 3, right 1. Dun, 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 dun. That's it. That's all you do. Make your line more beautiful than mine. And don't do those crazy arrows that I don't know what's happening. Okay, on B, we start at the origin. And your slope is what? -1/2. So, are you going to go up this time or down? Down how many? 1. And you always go to the right. And you're going to go to the right too. You could also go up and left. Okay, what about C? What do I need to do first? Divide. And what is 2 divided by 3? 2/3 x. Okay, so where am I going to start at? The origin. And what am I going to do first? Am I going to go up or down? Up how many?
2.
And right how many?
3.
Good, take a point. And the last one, what do I need to do?
And 5.
So it's negative 1/4 x. Am I going to go up or down? Down how many?
1.
Right how many?
4.
Dun, 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 dun. We're going to skip that bottom one for now because I want to practice the problems we really need to practice with direct variation. Now, y, k, and x all work together to form direct variation. You're going to need to be able to graph these on your test, which you're going to get your study guide in a minute, just in case I don't see you tomorrow. But you can also solve equations with it. So go to the back to 32, 33, whatever this is. This one. Alright, so our first problem that we're going to do says, suppose y varies directly as x so this is what it'll say every time. This is what it means by direct variation. Y varies directly as x. So as x increases, y increases. As x decreases, y decreases. Does everybody understand? So, and y equals 72 and x equals 8. Write an equation. So, we know that our equation is y equals kx. And we need to find k because they don't give us k, right? If they don't give you k, find k. Do we know what y is? What is it? Okay, we don't know what k is, so we just write equals k. And do we know what x is? What? How could we find k? Grant.
You, you divide by 8.
You do divide by 8. And what is 72 divided by 8? 9. So then, it says write an equation. Your equation would just be y equals 9x. That's it. That's all you do. What is happening? Get it together.
I nodded, because I already did that.
That's not what I mean. Just like with life over there. Does anybody have any questions? Is it easy peasy? Are you ready to do another one? Okay. B is in potato. I want you to use the direct variation from A find x when y is 63. So we're going to use our green equation. It wants you to use this direct variation. So we're going to use it, and we're going to say y equals 9 times x. Now, it wants us to find x when y is 63. Do you agree? So what are we going to plug in? And we're going to plug it in for x or for y? So we say 63 equals 9 times x. Well, what would x be, taters? Y. You do. That's it. That's all you do. You plug it in, you find your missing pieces. Do we need to do one more just to be safe? Does anybody want one more just to be safe? Okay, we'll do one more. Don't be babies. All right. C as in potato. If y equals 6 when x equals 10, find x when y equals 18. Do you want to do it together? We can do it together. Alright, so all you do to start with, plug it into your y equals kx equation. Now it says if y equals 6 when x equals 10, we don't know what k is, do we? Okay, so let's plug it in and get k. 6 equals k times 10. Alright, so then I divide both sides by 10, and k equals 6/10, which reduces to? What goes into both 6 and 10? What's 6 divided by 2? 10 divided by 2? Alright, so then it says, find x when y equals 18, correct? So you're going to say, y equals 3/5 x. And we need to plug in 18 equals 3/5 x. How would we get rid of that fraction? Multiply by what? The reciprocal. Take a point, which is 5/3. Alright, 3 goes into 18 how many times?
60.
And 6 times 5 is? 30. So x is 30. Questions, comments, gripes, complaints? Alright, you ready for your study guide?
Yeah.
So what's going to happen is